5.7 deals with the inverse trig function. So we've dealt a little bit with this. If we know the side length, then what is the angle if the sine is equal to 1/2 or if the tangent is equal to 1. And so we've worked some of them through on the calculator, but thinking of them graphically, a very rough sketch of the sine function. If it starts at 0, 0, and it again reaches a max of 1, intersects, decreases to the min of -1, and then continues on and on, this is a function. This passes the vertical line test. Whenever we talked about the vertical line test, that was just to deal with if it's a function, if it only passes through once. If we looked at a graph and said, is the inverse a function, that was the horizontal line test. So this was looking at the inverse. And if you see here, if we pass a horizontal line through here, it's going to intersect many times. And that is because if we were to reflect this over the line y equals x, instead of snaking around the x-axis, it's going to instead do that on the y-axis. And so it would look something like this. Not much like that, but the gist of it would look something like that in a condensed version. So because of that, when we talk about inverse functions, we look at just a snippet of them. So just one part of the graph that will in fact be a function and pass the vertical line test. Because again, if you think of the unit circle, all the values repeat anyways. So there are a ton of notes from the book. Here are a couple of pictures just to talk through. So the inverse trig functions, this is the little snippet here for that sine inverse. So it does in fact pass the vertical line test that way. This means that I still look from -1 to 1, but instead of that being my range, like what we were used to with the sine of x, it's now the domain. That's what happens when we find inverses. The x's and the y's switch. And my range now, I'm looking just from -π/2, which is really like going to 3π/2, and +π/2. So I have to make those adjustments when I am trying to find these values. The cosine, the same thing happens, domain and range flip. So I go from 0 to pi, and then tangent has the same range as the sine, but if you notice, we have brackets here and parentheses here. So if you take the sine of the inverse, it should kick back out whatever your input was. This was one way to check inverses, was with function notation. If f inverse of x were actually equal to x, so if it undoes all of the operations, then that was one way to confirm that they were inverses. And so we see this happening, but again, it switches between the domain and range as to whether it's the function that comes first or it's the inverse that comes first. And then cosine and tangent, the same thing happens with all those values. So some of the other pictures from the book, recognizing these restrictions, this is really just putting into words and telling you how to say what that means. The sine -1 of x is not how it's said. It's that it equals the inverse sine of x, and then tells you what to do. So if you take a look here, if we're trying to find the angle measure, then we can rewrite it as the inverse sine of x. And if we look at the table, all of these values on the table that we're used to are from the unit circle. So again, this portion of it is what we're used to in the first quadrant. This portion of it, working backwards now, really then just takes me down into the fourth quadrant. So again, if I'm thinking of quadrants 1, 2, 3, 4, this dealt too with our even and odd functions. So 1 gives me all the positives, quadrant 4 gives me all those negative values. And at that point, it's going to be a function. If you went from 0 to pi on the sine graph, this is from 0 to pi. And so while this is a function, it passes the vertical line test, the inverse would fail. And so that's why we have to work backwards instead in this direction and not use the values from pi over 2 to pi. So a lot of the same numbers we see with cosine. And again, this is just a little bit of vocabulary and restating what was in that summary table above about the domain and range, finding the exact values. So this same thing happens here, but because cosine starts at 1 and then goes to 0 and then reaches -1, I can see for my cosine that I have all possible values from 0 to pi, which is quadrant 1 and then quadrant 2. And so that first half of it, if we think of it that way, is in fact a function and also passes the horizontal line test. So the inverse cosine is the function. Now, tangent is a little different because it was shorter anyways. We had a period of just pi instead, and it also didn't reach the max or min that sine and cosine did. And so whenever I look at the inverse now, I see these infinities here for all of those values of x. And then these are not directly on our unit circle. These are simplified from that. But because I also have to be between -pi/2 and pi/2, I actually stop at my -pi/3 and pi/3. It can't be equal to those values because we have undefined answers at that point for the tangent, because it would be 1 divided by 0 or -1 divided by 0. And then my square roots of 3 come from at pi/3. It's the square root of 3/2 and then divided by 1/2 for y/x. And then this is simplified from that reciprocal where it's 1/2 and then the square root of 3/2. So we have to rationalize the denominator. You don't have to go through those stages, just so it doesn't seem like it's magic where that comes from. And then this is just like the sign. So we are in quadrant 1 here for all those positive values, and we are going down into quadrant 4 for those negative numbers. So what we need to be able to do, and we do quite a bit of it just on the calculator. So looking at the questions here, there are so many of them. So we actually did multiples of 5 on this one. If you look at the sine inverse of -1/2 and think of where that happens. So those would be these shorter triangles here that fall down into the third and fourth quadrants. They give me a -1/2. The issue though is that whenever we work through this on the calculator, this is not within the domain. And this on my unit circle is really 11 pi/6 if you take a look at it. But rewriting that angle so that I'm working clockwise instead of counterclockwise, this is the same thing as -pi/6. And so even though we can pull those values from the unit circle, it's recognizing with the inverses that we just have some restrictions now that we have to deal with. So that doesn't happen all of the time, just some of the time. My cosine inverse of -square roots of 3/2. So again, this is going to happen in my second and third quadrant, but I'm not going to use the third quadrant. So if you find -square roots of 3/2 on the calculator, or I'm sorry, on the unit circle, it's 5 pi/6. My answers for the cosine inverse have to be between 0 and pi. And so I don't have to adjust my 5 pi/6. That one's a little bit easier. And then my tangent of 0 is going to happen when I either take 0 divided by 1 at 0 degrees or 0 divided by 1 at pi. And again, because pi is outside of my restricted area, pi is not a valid answer. It would just be 0. Now, for all of these, you can put it into the calculator if you really want to, but the issue is that it says exact value. So if you were to, it's probably easier to have your calculator mode in degrees and find the value in degrees and then just multiply by pi over 180 to find it in radians than it is on the calculator to get the decimal point for the radians. Now, a little bit easier then when we're not working with the exact value, our calculator should just cooperate for things like 20, 25, and 30 if we're sticking with the multiples of 5. So if you just key the sine inverse of 0.47 into your calculator while you're in radian mode to 2 decimal places, you should get 0.49, it should round to. And then for 25, if you key this value in, because again, the 0.47 and the square root of 5 over 7, these aren't values that are on my unit circle. And so you would never be expected to find the exact answer at that point. You should get 1.246, which again, to 2 decimal points is really 1.25. We're not going to write in terms of pi when we're using the calculator to find it exactly. And then the tangent for number 30, I have about negative 1.56 for that particular value. So when it's exact, we can use the unit circle. And when it's not, we can just simply use the calculator. So working through a few more here, which was at the beginning of the notes where we have to find the exact value, but it depends on the direction that we're moving in. So if we have the sine of the sine inverse of 0.9, then whenever we work through that, we do end up just kicking back the 0.9 for my inverse. So let's find one where that doesn't happen. Let's look at 35. So this again, because it's the sine inverse of the sine at 5 pi over 6. So the sine at 5 pi over 6, again being in the second quadrant, is going to be a positive value, but 5 pi over 6 is out of my restricted area for the inverse. And so if I think it's positive here in the second quadrant, I need to recognize that it is reflected over the axis and also positive at pi over 6, which is an acceptable answer. My answer has to be between negative pi over 2 and positive pi over 2 where that's happening. And then take a look at 36. So the same thing happens here with the cosine inverse of the cosine of 4 pi over 3. So 4 pi over 3 actually puts me down here into the third quadrant. Cosine is also negative up here in the second quadrant, and my answers have to be in either quadrants 1 or 2 so that they're between 0 and pi for cosine. So I have to recognize that that 4 pi over 3, if this is really like 3 pi over 3, then it's pi over 3 away. So this one that it's reflected to, and this is probably easy to see, I hope, on your nice copy of the unit circle, is equal to 2 pi over 3. So one more where we see this happen would be something like 42. So the tangent inverse of the tangent of 3 pi over 4. So 3 pi over 4 is right here, splits it in the second quadrant. But again, tangent is like sine. It needs to be in the first or fourth quadrant. So a little tricky here though. Tangent is positive in the top right and bottom left, quadrants 1 and 3, and it's negative in 2 and 4. So I can't just reflect over the y or x axis like we did in the last two problems. I have to look at what the value would be down here in quadrant 4. And I can't use 7 pi over 4. It's equivalent at that stage, but that's not what I'm allowed to write my answer as. It's not between negative pi over 2 and pi over 4. Pi over 2. Negative pi over 2, positive pi over 2. The answer, if I work backwards from here, is negative pi over 4. Because that is just going a quarter down below. So the calculator helps on a lot. The unit circle has been such a good friend to us on so many of them. And then questions like 31 to 46 take a little bit more work. Have those notes in front of you so you know what the restrictions are. And try just a couple of them, and I'll have the answer key posted in the classroom for you to check your work.